I had used the popular operational amplifier integrated circuit 741C long back, but did not know much about operational amplifiers. If I remember correctly, it was the first ever integrated circuit which I used for my hobby electronic projects. A great upgrade from germanium transistors and occasional silicon transistors in those days. I was thrilled to use a device with so many transistors, resistors and capacitors inside a tiny chip, that too with a great amplifying factor. They are known in short as op-amps and can be used as amplifiers, active filters and in analog computers, which were popular in the early era of electronic computing before digital devices took over. Though operational amplifiers have a very complex circuit inside, they are represented in circuits with a very simple symbol with positive and negative voltage inputs, a single output and positive and negative power supply leads. Power supply leads are often omitted in diagrams as they are presumed to be there for all active devices like transistors and integrated circuits which need their own power supply, unlike passive devices like capacitors, inductors and resistors which do not need their own power supply. Op-amps have two inputs, an inverting input represented by V minus and a non-inverting input represented by V plus. Ideally, op-amps amplify only the difference in voltage between the two inputs known as the differential voltage input. V out, the output voltage of the op-amp will be AOL multiplied by V plus minus V minus. AOL is the open loop gain of the amplifier and refers to the absence of an external feedback loop from the output to input. AOL typically is very high, of the order of 10,000. To get an idea of the complexity of internal structure of op-amps, a review of the schematic of 741 op-amp will be useful. The differential amplifier outlined dark blue provides high differential amplification, low noise and high input impedance. It drives the voltage amplifier outlined in magenta, which provides high voltage gain. The voltage amplifier drives the output amplifier outlined in cyan and green. Output amplifier provides a high current gain with low output impedance along with output current limiting and output short circuit protection. Red outline is the bias circuitry and 30 pF is the compensation capacitor meant for prevention of self-oscillation.